You know, there's this hidden superpower lurking inside almost every computer out there, yours included, whether it's a laptop, a desktop, or even your phone. It's called OpenCL, and it's a piece of tech that can turn your everyday machine into a mini supercomputer. Let's dig into how. I want you to think about this for a second. We all know graphics cards are awesome for making games look incredible, but what if that very same chip could do something, well, way bigger? What if it could help tackle some of the world's most complex problems? Turns out it can, and that's exactly what we're going to explore today. So, how does this even work? Well, to get it, we first need to look at the different kinds of brains that are inside your computer. You see, you've got different processors, and they are not all created equal. They're actually designed for completely different ways of thinking. And understanding that difference, well, that's the key to all of this. Okay, so think of your computer's CPU, the central processing unit, as the manager. It's brilliant. It's a genius at juggling a few really complex tasks, one after the other, keeping the whole show running. But the GPU, the graphics processing unit, that's completely different. It's like a massive workforce, thousands of workers who are hyper-specialized. Now, they can't do the manager's job, but they can do thousands of simple, repetitive tasks all at the same time. This is what we call parallel processing. And trust me, it's incredibly powerful. And that brings us to this really key idea, GPGPU. It stands for General Purpose Computing on Graphics Processing Units. It's basically the concept of giving that giant GPU workforce jobs that have nothing to do with graphics. But here's the catch. How do you actually talk to that workforce if you're not a game developer? How do you unlock all that power? And that's where we need some kind of universal key. A way to open the door to that massive workforce, no matter who built the computer or the chip inside it. And that is OpenCL, the Open Computing Language. Now, the most important part here is that it's an open standard. Think of it like a universal language, a set of instructions that any software can use to talk to almost any GPU, whether it's made by Intel, AMD, ARM, you name it. It basically smashes down the walls between different hardware brands. The whole goal here is simple, but it's totally revolutionary. Imagine this. A developer can write a program once, and boom, it runs everywhere. This lets them massively accelerate these super complex calculations, and they don't get locked into one company's hardware to do it. For developers, this saves an unbelievable amount of time and money. So how does this universal key actually work in practice? Let's go back to our analogy of the manager and the workers, because it makes it all make a lot more sense. All right, so here's the play-by-play. First, the CPU, our manager, gets all the data ready and writes up the instructions. These instructions are packed into a tiny but super important program called a kernel. Think of it like a blueprint for one very specific job that's going to be repeated thousands of times. The manager sends that blueprint and all the raw materials over to the GPU, our workforce. The workers then take all that data, split it up into thousands of little pieces, and every single worker does the exact same task from the blueprint on their piece all at the same time. Once they're all done, the finished results get gathered up and sent right back to the manager. It's like the most efficient assembly line you've ever seen, but for data. Okay, so this digital workshop sounds amazing, right? Super efficient. But what does it actually build? This is where it gets really mind-blowing. The real-world uses for this stuff are incredible. In the world of science, OpenCL is a total game changer. Researchers are using it to run these unbelievably complex simulations, like predicting the path of a hurricane or modeling how proteins fold, which is absolutely critical for developing new medicines to fight diseases like Alzheimer's. Then you've got finance, where speed is literally everything. OpenCL lets these firms chew through massive amounts of data in real time, calculating market risks and spotting trends in just fractions of a second. This is supercomputing power pointed directly at the global economy. And of course, it's used right where it all started, in the creative world. The special effects in your favorite movies rely on this kind of parallel processing to render all those stunning animations, turning what used to be days of rendering time into just a few hours. And maybe the most important part of all? It's literally saving lives. When someone gets an MRI or a CT scan, OpenCL helps doctors take all those flat 2D slices and rebuild them into a detailed 3D model of a person's body. This means more accurate diagnoses and much better planning for surgeries. Now, this all sounds pretty incredible, right? But, and this is a big but, OpenCL isn't some magic wand. When you unlock this much power, it comes with its own set of very real challenges and some pretty serious trade-offs. For starters, it's really hard for programmers to learn.
You have to completely change the way you think to program for thousands of cores at once. And debugging? Trying to find one tiny bug when thousands of things are happening simultaneously is a nightmare. Plus, there's a physical traffic jam. Just moving all that data from the CPU's memory over to the GPU's memory can sometimes take so long it cancels out the speed gains. And since it all depends on hardware drivers from different companies, the performance can be, well, a little all over the place.
And this all leads to the big trade-off for developers. On one side, you have OpenCL. It's the open standard. Its greatest strength is that it's built to work everywhere. But because it has to be a jack of all trades, it can't be perfectly optimized for any single piece of hardware. On the other side, you have things like NVIDIA's CUDA. It's a walled garden. It's often way faster on its own hardware, but it locks you in. You're stuck in their world. So a university lab might pick OpenCL so their code works on all their different computers, but a big Hollywood studio that only uses NVIDIA cards, they're probably going to stick with CUDA to squeeze out every last drop of performance. So that leaves us with this huge, fascinating question. As our need for more and more computing power just keeps exploding, which path is going to win out? Is it going to be the freedom and flexibility of an open standard that works for everyone? Or will it be the raw, specialized performance you get from a closed system? The answer to that? Well, it's going to shape the future of technology for every single one of us.